Yeah, so good evening, students. Welcome to the session number 8 of this chapter. So, you see, probably another three sessions we can close this chapter. We are almost heading towards the 60% or 65% of this particular chapter. Okay. So, let me give a quick recap only from the last session. I'll repeating student because very important sessions are going on. From the last session, session number 7, all the 5 mark questions will be framed from last 4 sessions. Session 7, session 8 today, session 9, session 10. Okay, all the 5 mark, 6 mark questions from these particular sessions only. Okay, so try to concentrate more, students. Let me give a quick recap of 5 to 7 minutes. Okay, so student, we have started the spherical mirrors. What are spherical mirrors? The mirrors that are taken from the spherical, big sphere is there. The small piece is taken out of that particular mirrors are known as spherical mirrors. They are generally convex and concave mirrors. Okay, how to differentiate? When we take the small piece, if at all the bulged part is painted and light entering from the cave, reflecting from the cave, we say it as a concave mirror. Okay, and if the same small bulged part, if the cave part is painted, light entering on the bulged part and light reflecting from the bulged part, we say it as a convex mirror. Okay, you can see here light is coming on the bulged part, reflecting from the bulged part, light is coming from the bulged part, reflecting from the bulged part, convex. Light is entering the cave, reflecting from the cave, light is entering the cave, reflecting from the cave. It's nothing but concave mirror. Okay. Now terminologies, as I said, very important six terminologies. Always we use these terminologies in the further sessions. Okay. So let me explain this easily all the six terminology at one shot, student. Okay. So this is a broken parts of a mirror. If somebody is asking you center of curvature, you should construct back whole sphere, construct a whole sphere. Then you should say, the big sphere center is here. It's a center of curvature. It's a center of curvature. Then what is radius of curvature? Obviously, from the center to the edge of the particular sphere or circle. From the center to the edge, from the center to the edge. These are nothing but the radius of curvature. Then what is pole? It is exactly center of the broken or center of the mirror itself is nothing but pole. What is principal axis? It's an imaginary line or a straight line that is passing through center of curvature also and pole also. Center of curvature also, pole also, that's the principal axis. What is aperture? It is the effective width from where the reflection can happen. From here happen, from here happen, from here happen. From here it does not happen. Why? The light escapes. So the effective width is nothing but aperture. Okay. And the last but very important the particular terminology is focus, student. So what is focus? Focus is nothing but if at all you take any mirror, a parallel ray which is parallel to the principal axis, after hitting it will reflect. Another ray after hitting it will reflect. When you find out the intersection point, it will be exactly on the principal axis, and that point is nothing but focus. That point is nothing but focus. Okay, student? This is what we have learned about the terminology. Then we went to the sign convention. I said simply whatever mirror you want to take, you take it. Always assume your mirror pole is at the origin 0 comma 0. Whoever is lying to the left, negative x-axis. Whoever is lying to the right, positive x-axis. Like you can see, object left side minus, image left side minus. Similarly, when the object arrow is pointing towards up, it is positive y-axis. Image pointing to arrow down, it is a negative y-axis. So positive height, negative height. Okay. In that way, you need to use sign convention where from the next session, we will be doing many numericals on sign convention. Okay. Yeah, as simple as that. Positive y-axis, negative y-axis, you should always take positive value, negative value. Negative x-axis, you should always take negative. Positive x-axis, always positive. And pole is my reference. It is as good as Cartesian coordinate system. Okay, students? Yes. Then we went to very important discussion of types of rays. Four types of rays. First ray, whenever ray is coming parallel, it should reflect to the focus. Second ray, whenever ray is going through the focus after reflection, it travels parallelly to the principal axis. Ray number three, whenever ray is going through center of curvature after reflection, it goes back in the same direction. Ray number three. Ray number four, whenever the incident ray hits the pole, it will just exactly looks like a symmetrical with respect to principal. Left side you watch theta and a green arrow. and right side you watch theta and a green arrow. It is as good as symmetrical, student. These are 4 rays. Okay. Then we went to the concave mirror. In the concave mirror, how many cases? Only 6 cases. This you remember these 6 cases. Finished. The game is finished, student. Okay. The game is finished. So what are the 6 cases? Cases are nothing but, sir, you need to assume object at infinity. Slowly, slowly you should produce further. So now object is moved towards the mirror, still move towards the mirror, still move, still move, still move, like that. Up to the mirror, you need to take the object and you should find out how is the image looking like. How is the image looking like? This is what you need to observe. Okay. So let us start with case number 1. Object at infinity. You can take any rays as it is infinity. Let us consider the parallel ray. After hitting, reflect. But only one reflection doesn't suffice our requirement. Another ray, another reflection. Now I can see exactly on the focus, the intersection has happened, and object is this much big, image is this much short, highly diminished, and image is exactly at focus. And why real and inverted? Yes, Chaitra, Sai Chaitra, why it's real and inverted image? Why real and inverted? I'm not able to see how the particular thing is, but how can I say it is real and inverted? Yes, anybody, student?
Sir, because the rays meet can are visible, sir.
Okay. So you mean to say, sir, these both are reflected rays, and whenever I'm speaking about reflected rays, that gives image characteristics. We have seen this. Whenever we are speaking on a reflected rays, that gives image characteristics. Now, as you are asking the image characteristics, these reflected rays actually meeting at one point. Whenever we say actually, not appearing, they are actually meeting. Real world comes. Whenever real world comes, inverted word automatically comes along with it. Okay, that was case number 1. Now let me give my object between infinity and c. At infinity and c, this is my object. Again, here also you can consider any ray. Let me consider parallel ray. After hitting, reflecting, but it should go to the focus. Okay, let me consider another ray, ray number 3. Whenever it is going to center of curvature, it will reflect back. So where is the intersection happening? Here. And where is the image coming from? Object rays coming from arrow. Let me consider arrow and construct back. Now, where is the image formed? Between C and F. How is the image formed? So, is it big or small? Small, diminished. And I'm also see, sir, reflected ray, reflected. They're actually meeting real. And also I can see that they are inverted. If real word comes, automatically inverted word automatically comes, and that is what it is inverted. Okay, these are the 4 properties of case number 2. Now some student ask, sir, can we take any other ray? Yes, you see case number 2 only. I am taking another ray. Case number 2. What are the first ray? I took a parallel ray. Second ray, I took ray number 4. What happened? Exactly here is the intersection happened, and again all the characteristics are same: diminished, inverted, real, between C and F. Same characteristics, no change at all. Case number 2. That's the reason, student, you can take any ray. Try to take the ray which you are comfortable in drawing. That's all. Okay. Then we have moved the object near center of curvature, exactly on center of curvature. What happened? Exactly on center of curvature. Parallel ray, it should go to the focus. Okay. Ray number 2 going to the focus after reflecting, it should go parallel to the principal axis. Ray number 2 going to the focus. Where is the intersection happened? Exactly here. When I constructed back, they both are same size. They both are inverted. They both are real. Why? Actually, rays are intersecting. Real or inverted word came real, and exactly the image is formed on the center of curvature. Case number 3. Okay. Now let me move my object still further between C and F. Between C and F, center of curvature and focus. So you can see object is here. Parallel ray. It should go to the focus. Ray number 4, it should follow the symmetry. When they both intersect, I have seen the image is formed between infinity and C, or else sometimes you can also call beyond C. Both are same. Beyond C. Both are same. How is the image? The image is highly magnified, enlarged. Okay, they are real. If real comes, inverted comes, or else I can look back, they both are inverted also. Okay, that was case number 4. Case number 5, where should I keep my object? At the focus. What happened at the focus? Parallel ray. Obviously, it should go to the focus. Any ray you take, student, ray number 2 you can't take it because I need to ensure from the top like this the ray can't be. It should touch the top of the object also. It should go to the focus also. It can't be. Ray number 3 if I take like this, it's still possible, but much chance it may escape the mirror. So that's the reason I'm left with only ray number 4. After that, it should reflect and I'm able to see they are exactly parallel. They can never meet. Sir, can't you extend backside? So I have extended backside also. Extended reflected ray. I tried the backside also. Backside also they are not meeting each other. That's the reason we should consider image would not be formed. Image would not be formed. Okay. Then the last case, very important case, object is very near to the mirror, or you can say object is between focus and pole. Focus and pole. What happens, student? Sir, one ray number 3 from the center of curvature to the top. Again, it should reflect back, but let me extend it backside. Why? You see, this ray 1 is ray number 4. After hitting this, it should reflect. They both will never meet better. So that's the reason. Let me extend it backside. Yes, extended reflected ray has intersected. As the reflection is coming from the arrow is here, remaining body part is here. Okay. So now how is the image formed? Image is magnified, image is enlarged, image is erect. Why erect? You seedha ka seedha. Virtual. Why virtual? Appear to meet. They are not actually meeting, they appear to meet. That's the reason virtual. If virtual comes, erect word comes. And where is the image formed? Behind mirror. Behind mirror, we generally say. Behind mirror. Okay, students, all the 6 cases are here. All the summary, whatever I said, that is here in your textbook. And finally, I asked to remember at least this shortcut. So what is the shortcut? If your object is moving left to right, your image will be moving right to left, but your image size is also increasing. You see green color dot, your object moved here, your image size increased, but moving left, still your object moved, your image still moved, still the size is increased. Like that, I asked to remember. Whenever your object is moving like this, your image will be like this, except the last case, which is exception, where the image is formed behind the mirror. Behind the mirror. Yeah, so student, that was a quick recap. So I intentionally took this much time because that is required. That is required. Any doubt, students? Any doubt? Ritika, how are you?
Good, sir.
Good. Okay, students, if that's fine, so let us proceed with today's session. Let us proceed with today's session. Okay, now the story comes. Yes, Vishnu Maya. Now you see, student, this is a mirror. All the images are forming in front of the mirror. In front of the mirror. And one image is forming behind the mirror. Now, which case we can directly see the images with our naked eye? Which case requires some special feature? You see, in front of mirror, the image is formed. Can we see with our naked eye? Yes, Vishnu Maya. I can't hear you. Can't hear you. Yeah, go ahead.
Can you hear me?
Now I can hear you.
Sir, the image is in front of the mirror.
No, student, your voice is
No.
disturbed. Yes, Ridhima. This is a mirror. All the 6 cases are here. Images, niche ka images. Which case requires some special arrangements? Which cases does not require special arrangements? You see, image is formed in front of the mirror. Image is from backside of the mirror. So where do you require some special features?
Sir, when the image is formed behind the mirror.
Oh, let us see. Okay, so she's saying behind the mirror, we require some special features. Okay, let us understand the same thing by the real practical session, student. Okay, practical thing. Okay, where is the criteria? Okay, so first of all, so let me take this practicals is there for SSC Telangana students. You have this practical in your schools. Okay, yeah, you see what did I take? V stand. Why? I'll keep a concave mirror over here. V stand. Okay, and you can see if a concave mirror is here, obviously I need to draw the principal axis. On the principal axis, there is center of curvature, there is focus, and exactly below this V stand, there is a pole. Okay, now what is the object? This candle is the object. Okay, this candle is the object. Okay, so now student, what will I do? Case number 1. What is case number 1? Object is at infinity. So student, infinity doesn't mean like mirror is here and the particular object is at Dubai. No, it doesn't mean that. It means it's only somewhat very far. It means somewhat very far. Okay, so obviously in this arrangement, what will I do? Yeah, so now you can see student, focus, center of curvature, object is nothing but the candle over here. Again, the entire candle is not the object, only the flame of the candle is the object, only flame of. So where am I keeping? I am keeping very far distance. That is nothing but infinity. Okay, so where should the image be formed? Image should be formed at the focus, okay. Okay. So you see, I have arranged this mechanism. Concave mirror is here. Now I am ensuring that particular rays are going to the concave mirror, hitting, and the image is formed. Now where is the image formed? At the focus. That's the reason in front of mirror means we should arrange some mechanism. That is nothing but projector, student. Projector. But here, as it is a very simple laboratory and it is for only your class purpose, we are keeping a white screen or white paper. White screen, okay? So in front of the camera, in front of the mirror means sometimes we are using screens like paper, projector screen, all those things. We generally use the word screen, okay? Where should I keep? At the focus. So you observe it here when I kept at the focus, and you can see here, student, this is what is perfect, a small point size image. You see, not this one. Don't look this particular top one. Yeah, you can see it here, student. You can see it here. It's a image of the candle flame. Candle flame was somewhat bigger, but can you see the image? It's a point size. And where did I keep the screen? I kept the screen at the focus. Now you can move the screen here and here, but the image will be distorted. For the perfect image, it can be only the screen should be kept only on the focus. Then only small but thick image will be formed. Small but thick image will be formed like this. This is case number one. Okay, so don't see this here, student. This is somewhat wrong diagram. What I see is okay. Now case number two. What is case number two? Case number two. Object is to be kept. Yeah, case number two. Object is to be kept beyond C or between C and infinity. Both are right. So just before C, I'll keep the object. You see the candle flame. Here is the center of curvature. Just before the C, I kept. Where should the image form? Between focus and center. Between focus and center. You need to arrange your screen here, here, there, here. Finally, you see the best image will be formed whenever you keep the screen between C and F. Between C and F. Okay, you see, student, this is the object, this is the image. It's still small, diminished only. It's still small, diminished only. Okay, between C and F, he has arranged it. It is still small. So, can you see the inversion happening? You see, thin pointed side is top, pointed side is down. That means real and inverted. Real and inverted. Okay, students. So the same thing, case number two, whatever you read that whenever object is just beyond C, your image is between C and F, inverted, diminished, all these things you can see here. Case number three, where should I keep the object? Object at C. Somebody asked some doubt. Huh? Okay. Image at C. So let us keep the object at C, student. Sorry, object at C. Object should be kept, that candle should be kept exactly on the center of curvature. Exactly on the center of curvature. Now, take your screen, arrange here, here, here. You'll not get the image. Only when you keep your screen exactly at C, you'll find a perfect image. Now you see, student, this is a screen. It should also be kept on the center of curvature only. That's the reason he kept just side by side. Just side by side. So can you see here, student? Your object distance, image, or your object height, image height, they are both same size. And can you see? It is exactly the inversion has happened. The pointed one is top, the pointed one is down. This is nothing but case number three. Same size of the object. You see, exactly same size of the object. Okay, exactly on the center of curvature only you can see screen also. Object also center of curvature, screen also center of curvature. Case number four, where should I keep the object? Between C and F. Where will I get the image? Beyond C. Beyond C. Okay, let me keep the object between C and F. So let us bring the candle light between C and F like this. Now, you can move the screen here and there, you will not get the image. But when you keep beyond C, you can see that it is magnified or enlarged, and it is ulta, inverted also. This is what we have seen it. You see, this is the object, this is the image. It should be big also, it should be inverted also. That is what your case number 4 is, student. Case number 4. Okay, fifth case, where should I keep the object? I should keep the object exactly at F. So student, this case, as I said, this is a little modified this year. So in the previous year, you can see object is kept at F. When he took back, a blurred image is formed. So that he was considered as an image, but right now you say no image formation. You see, they are parallel, no image formation, but you can see it's very lightly blurred image over here. So don't consider as the image, okay? So object case number 5, no image formation. Okay. Last case, very, very important case. I should bring between pole and focus, or else you can say very near to the mirror. Very near to the mirror. So now let me see whether I require screen or not. Very near to the mirror, he kept student. You see, this is the mirror. This is the object, focus and pole. It is between focus and pole. When you look at the image, it is exactly inside the mirror, beta. So here we don't require any screen. Okay, it is just as good as I have explained. Where go back and check your at your home plane mirror, and you see your image is not on the mirror. Your image is inside the mirror. Same case is this. Case number 6. Even though we say image is formed behind the mirror, we can see inside the mirror like this. Inside the mirror. Okay, technically it is behind the mirror, but physically we can see very deep inside the mirror, not on the surface of the mirror, deep inside the mirror. Student, anybody, any doubts in this particular practicals? Yes, Pranav, no doubt. Ridhima, cleared better now? Okay. Okay. Lavanika, clear?
Yes, sir.
Okay. So student, so this is what I thought to explain this particular all the cases. So we have taken each step by step also. We have seen the particular shortcuts also. We have seen practical cases also. Okay, student. Yeah, there is some simple pendulum activity also. I'll show it later. It is little bit confusing where we can see without the screens also. Without the screen also, we can see all the 6 cases. Okay. But anyhow, so that's not required. It's a little bit confusing for your class test. Let us only explore this situation. Okay. Yes, students. Oh, I'm sorry. I have not shared the screen. Nobody is saying. Okay, so I said that there is another activity known as simple pendulum. One scientist is there. He was just moving a ball, and where he is explaining all the 6 cases. That is also absolutely fine. Without the screen, also we can see the quizzes. Okay, but for your class, it is little bit confusing. Let's not go for this. It's not important. It's not there in syllabus. I found it important. Whenever there is a time, whenever such question I come, I'll definitely explain this. Okay, yeah. So now think, student. Keep in your mind all the 6 cases. Again, I'm asking, student, you should remember these six cases by hook or crook. 6 plus 2 cases you need to remember. Okay. Now compare this situation with which case? I'm already giving the clue. This is nothing but a concave mirror. This is nothing but concave. Here is the object. Here is the image. Here is the object. Here is the image. Now don't just say, sir, there is no screen. So that will be sixth case. No. As I said, there are some cases, mirrors, concave mirrors, where all the cases can be visible without the screen also. So just think about object and image characteristics and then give. Look at the object, look at the image, think about the characteristics, match the case. Now type which case is this. Case number 1, 2, 3, 4, 5, 6. Object, image, and I want the case. Just think about the image characteristics, not about the screen. Image characteristics only you should think. Image characteristics, not object characteristics, Pranav. That is what I said. So don't think about object characteristic. It is not in our hand. Object can be, he can move that particular mirror here and here. That's still fine. Only think about the image characteristic compared to object. Yes, very good. Lavanika, right answer. Pranav, right answer. Give me the case number. Lavanika and Pranav, give me the case number. I want that case number. Yes, very good, Pranav. Right answer. Again, Ridhima, don't think about the object position. Think about, compare the object image characteristics, then give the answer. Lavanika, right answer. So don't position the object infinity. No. Think about how the image is looking compared to object and what is the case. Some student got idea. Very good for that. Yashashvi. Okay. No Yashashvi. That's not the case. Vishnumaya, right answer. Very good. Okay, I'll help out. Yes, Rishit.
Sir, I sent the answers.
Send the answer. Okay, Ridhima. No. Ridhima, no. Ritika, very good, right answer. Okay, Rishit, I'm not seeing the answer, but still I want to take your help.
Okay, sir.
Okay, Rishit, see this fellow is object.
Yes, sir.
He's seeing his image. Is the image enlarged or diminished?
It is enlarged, sir.
Enlarged. So now you say, if it is enlarged, how many cases it may be happening? Okay, you can see, student, this is
Case
our
number 4 or 5.
very good. 5 we don't have any image, beta. Don't get confused at all.
Okay.
Okay,
Sir,
so
it's 4th. Case number 4.
okay, I'll come to that point. So, student, enlarged means only case number 4 or 6. Case number 4 or 6. Okay. Now again we need to filter out these two cases. Now again let us go back to the object. Yes, Rishit, same you. This fellow, his hair on the top, image hair is also on the top. Is it erect or inverted? His
It's
hair.
inverted.
So that means object hair is on the top and the image hair in the down. Is it like that?
No, sir.
It's Sida ka Sida only, right?
Yes, sir.
So what is erected or inverted?
Erect, sir.
Erect, Sida ka Sida. So student, now you need to filter that. Sir, it is enlarged, not only enlarged, it is erect also. Obviously, it's case number 6.
Oh.
Understood, student? This is how you need to filter out all the numericals also. You should compare the image characteristics with the object. Then, if it is still confusing, you should again compare with the next properties. Okay? Next property. Anybody, any doubt? Ritika already gave the answer. Yashashvi, now is your doubt clear? Yashashvi, please switch on your video also.
Yes, sir.
Please switch on your video also. Okay, so here, student, we use this case where we use in the parlors, in the saloons. Okay, whenever we want to maximize our image and see that every the finest finishing, so they use this mirror. So high-ended mirror, student. These all are okay. Not in the normal saloons or parlors you find it. Whenever you go for the very good saloons, there you will be seeing such type of mirrors. Okay, so it's nothing but the 6th case of the concave mirror. 6th case of the concave mirror. Okay. So if you remember, try to give the answer. If you don't remember, see whatever you have in your page written in it, that summary, look at that and give the answer. I want everybody should give the answer, right or wrong. Lateral inversion is still right, Yashashvi. Acha, so you use the word lateral inversion. Okay. So lateral inversion is the last case where we will check, student. All mirrors will go for lateral inversion. That's the reason we don't take that lateral inversion word. Whether it is plane mirror, concave mirror, convex mirror, all mirrors will have lateral inversion. Ritika, oh wait, what is the question? Yes, right answer, Ritika. Yashashvi, right. Vishnumaya, no. Ridhima, right. Lavanika, right. Pranav, right. Sai Chaitra, right. Come on. Yes, Rishit and Vishnumaya, try to give the answer again. Okay. Okay, so once for again I am explaining, Rishit. Object is between C and F. Object is between C and F. Okay. So 1 second, student. Let me give him clarity, or else he will be missing most of the question. So you see, first case, object is at infinity beta. Second case, object is between infinity and C. Third case, object is at exactly on 3. Exactly on C. Fourth case, object is between C and F. Now you say me which case is the question?
Between C and F.
So what is the number? Fourth.
4 number.
Okay,
4.
fourth number. Okay. Now let me draw the images for you. So object in infinity, image is on the focus. Now object has moved here. Image will be moving here, but slightly increasing. Object has reached center of curvature. Image is also on the center of curvature, same side. Object is moving to the fore. Image will moving over here. Now you can see. So where is the image formed? Between C and infinity or beyond C. Understood, Rishit?
Yes, sir. I'm giving the answer, but it's... Sir, can I rejoin once?
Region, so. Vishnu Maya beyond C, right answer. Okay, between C and infinity or beyond C. Yes, others. So try to use your thing from the mind, student. There are some things to remember. Okay, so this 6 plus 2, I'm asking only this 6 plus 2. Don't remember the length cases. I'll help you out how to remember, how to give the answer. But these 6 cases, if you understood, still you need to remember. Why? You can't always think in this big channel. When the object is between, so there may be dual answer for this. Huh? I'm giving a clue. There might be two answers for this. So give both the answers at a time. Give both the answers. Vishnu Maya already give. Very good. So that's the confidence. Without me telling only, she gave the two answers. That's the confidence. Yes, right answer. Lavanika, Vishnu Maya, Sai Chaitra, Ridhima, Ritika, Yashashvi. No, Yashashvi only half answer right. Again think. Again think. I'm giving a chance. Pranav half answer right. Case number 4. Your image is like this. C, F. At least now you give the answer by looking this. Yes, right answer. Pranav. Okay. Image is enlarged also right. Inverted also right. And if inverted, real word automatic color. B and C should be your answer, student. Yes, B and C should be answer. Yes, yes, yes. When the object is between F and pole, now you see, student, which case is that? You need to think about that. Then you need to look at the options. Students who are switching off the camera without my permission, I'll remove you from the sessions, please. A sincere request. If you are really want to keep the camera off, give me the valid reason. I'll ensure that I'll give an excuse. Okay, because last year this has happened. One student was not attending the sessions, and the parent called me, my kid is not in front of you, whom you are teaching to. So that was a very embarrassing situation. Okay, so for that reason, I'm not giving a freedom to the students of switching off the camera. Yes, Ritika, right answer. Sai Chaitra, right answer. Lavanika, right answer. Vishnu Maya, right answer. Ridhima, right answer. Yes, Rishit, which case? Between focus and pole beta, which case is the particular?
Case number 5 or 6.
Case number 5, exactly on the focus. Easy saying exactly on focus?
No,
Then?
sir. And Paul. Case number 6.
Case number 6. Very near to the mirror or between focus and pole, this case number 6. Now give your answer, Rishit, then. Be vocal. You can give it loudly also.
Okay, sir. Image forms behind the mirror.
Okay, right answer. When the object is placed between infinity and C of the concave mirror, yes, Yashashvi, which case beta? Infinity and C. Yashashvi, can you hear me? Which case is that?
Sir, case number A, sir.
Case 1, 2, 3, 4, 5, 6. Which case?
I don't know the numbers, so can I tell the options, sir?
Okay, no problem. You give the option in the chat box.
Image is formed between C and F, sir.
Okay. So infinity and C beta. So it's case number 2. First object is at infinity. Second object is just between infinity and C. Case number 2. Your image will be formed between C and F. C is the right answer, student. Many of you gave the answer. Huh? Yes, yes, right answer. Ritika, Vishnu-Maya, Sai Chaitra, Lavanika, Rishi, Pranav. There may be two answers, right? Again, give both the answers at a time. Don't type B and C. You should type A and B and then type enter, student. Or else all your answers will be mixed here. Right answer, Ritika. Lavanika, no. Pranav, right answer. Ridhima, very good student. Sai Chetra, always awesome. Yashasvi, little confusion still. Lavanika, adjusted, right answer. Vishnu Maya, same confusion. Half confusion. Come on, Rishit. Rishit, which case is this? Be vocal.
Case number 1 or between infinite and C.
Case number 1, object is at infinity, beta. Case number 2, object is shifted from infinity to C.
Okay, between infinite and X. Infinity.
Okay, then what are the options?
The image is diminished,
Diminished, right answer. Then
inverted and virtual.
virtual means Sida, beta.
Okay. Inverted and real size.
A and D should be your answer. Yes, we should be right answer. Okay. Case number 2, it is real and inverted. Yeah, you can look at here. Small also, inverted also. So students who are raw, not writing the notes, believe me, whenever there is exam, you will be taking more time than the students who are writing the notes. Why? First of all, you will forget the things. Not only you, it's with everybody. All our minds are volatile. You will forget the things. Be sure after 2-3 chapters, after you start the school, you will forget the things. At least 20% of that. For that, you will again be revising entire thing. That will be totally time loss for you. Students are maintaining the notes in a shortcut way. You are at the best place. Yashasvi, right answer. Lavanika, right answer. Vishnumaya, right answer. Sai Chitra, right answer. Ridhima, right answer. Pranav, right answer. Yes, Rishit, what is the right answer?
Sir, it's case 5, right? Or case number 6.
List of few coordinates when an object is placed between focus and pole, beta.
Okay. B, sir.
D. Okay, all of case number 6. Pole, focus and pole means very near to the mirror. Case number 6, it is D. Virtual, behind the mirror, erect, and all the
Okay, sir.
this is the right answer. Okay, okay, students. With that, let us go to the concave mirror also. Let us go to the concave mirror also, students. Now I can see your message, but they are very late.
Okay, sir.
Okay, okay, students. So what is concave mirror? Concave mirror is this. Why we are saying concave mirror? Light is coming and hitting on the bulged part, and light is reflecting from the bulged part. Sorry, convex mirror. I'm really sorry, convex mirror. Light is coming on the bulged part. Light is reflecting back on the bulged part. So it is a convex mirror, students. So now we are moving to the image formation case of a convex mirror. Convex mirror. Okay. Okay, so again here is also Acha, okay. So student, in the concave mirror, how many cases we had? 6 cases. So slowly, whenever I was moving from infinity towards the mirror, all the image properties are changing. We have divided into 6 cases finally, from infinity to the mirror. But here in the convex mirror, we have only 2 cases. Only 2 cases. What does that mean? Whenever object is at infinity, we will get some image characteristics. After that, you take image object position anywhere between infinity to the pole or near the mirror, all will have same characteristics, students. That's the reason we have only two cases here. It doesn't mean I am not shifting the thing slowly like that. I am shifting the thing slowly, but only at infinity we get different characteristics of the image. From the infinity to the pole of the mirror, we always get the same characteristics. So there is no reason to learn 6 cases. You can only learn 2 cases. Understood, Vishnu Maya? Why 2 cases? Okay. Vishnu Maya, your mic is not working. Okay. Okay. So image formation by convex mirror. You see why this is convex mirror? Sir, convex mirror, you see inside cave part is painted. Light should come from the bulged part. Light should go back from the bulged part like this. Okay, student? It's a convex mirror. Now, okay. Now, yeah, that's fine. Okay, let us keep the object at infinity now. Let us keep the object at infinity. Okay. Here I'll keep student very infinity. Obviously, now I need to choose ray number. Obviously, as it is at infinity, let me choose the best ray is a parallel ray, a light ray coming from the top of the object also, hitting the particular mirror also. Yes, Ritika, what should be my next step, beta? Once the ray is incidenting,
The normal.
normal. So where is the normal here? How to draw the normal? So normal in the circle, normal in the sphere should be what, beta? We have discussed this. Yes, Pranav, I should draw the normal beta once incidenting. So how should I draw the normal? We have discussed this.
Sir,
Yes, anybody? Open question. How did we draw the normal in the concave mirror, students? Forgot already.
sir, we draw tangent from the.
Okay. So tangent is a procedure to draw. But now I'm asking, what is the particular specification of a normal to a circle? If there is a circle, if I'm saying normal, is this a normal or the line that is going to the center is the normal?
Going through the center.
That's what I said, student. Okay. So, student, this is nothing but an incident ray. Now, as she said, that we should draw the normal. Next question comes, the normal means how to draw. As it is a spherical mirror, this is nothing but the total sphere. This is nothing, a total sphere. So, if I want to draw the normal, how should the normal be? Normal should be passing through the center of curvature like this. Like this. Understood, student? Incident ray, once it hits, I have drawn the normal. How is the normal going? Normal should always go to the center of curvature. Center of curvature. Okay. Yes, Lavanika. Is my green a reflected ray or is my blue a reflected ray? So this is a mirror.
Sir, the green arrow.
Very good. Okay. Obviously, green. Why? If this is 30, this should be 30. If you're taking blue one, this will be 60 degrees from normal. So that's the reason, student. So incident ray, it should be this should be a reflected ray. This should be reflected ray. Okay. So Sai Chaitra, what is the property of a light ray which is parallel to the principal axis? What is the main property of the ray that is coming parallel to the principal axis? After reflection, what should it be done?
It passes through the surface.
Very good. Student, you see, as it is a convex mirror, it is definitely going away. But I need to ensure that this ray should pass through the focus also. That's the reason, student. We will extend the reflected ray and will ensure that thing is going to the focus so that the particular law is followed. Particular law is followed. Whenever light ray is coming parallel to the principal axis, after reflection, it should go through the focus, and that is what we have extended over here. Okay. Yashashvi, is the image formed or should I take another ray?
It is formed, sir.
Where is the image formed?
From the ray. We should take another
So student, image is only formed. At least two reflected rays should intersect. So only one reflected ray, and we have extended backside. So I should take one more incident ray, one more reflected ray. So let us consider another incident ray. Again, once the incident ray is drawn, what should I draw? I should draw the normal, and the normal should be going through the center of curvature like this. Now, if this is an incident ray, what should be my reflected ray? My reflected ray should be like this. Why? I need to maintain a angle. I'll make it like this. Why I need to maintain this angle same. That's the reason my reflected ray should be like this. Okay, but again, you see this fellow is going here, this fellow is going here. Will they ever intersect? No, they are divergent rays. They will never intersect. But I know that whenever ray is drawn parallel to the principal axis, you see this is the principal axis, this is a ray parallel to the principal axis. Okay, when these two rays are parallel, it should go through a focus. So what will I ensure? I will draw the extended reflected ray. I'll ensure that is passing through the focus. Okay, yes, Rishit. Now you say the properties. This is my object. This is my image. Give me the position of the image.
Between. So can you repeat it?
This is my object. Here is the intersection happening. So can you give me the position of the image? Where is
Focus.
it? At focus. Be confident. At focus. Yes, Pranav. What is the size of the image compared to the object?
The size of the image is diminished.
Okay, point size. Very small. Riddhima, can you say about erect or inverted beta? Let me see.
So it will be erect.
Erect. If erect comes, virtual word will come. Why beta? Why it is virtual?
Because the image is formed behind the mirror.
Not probably. So you are considering this side is behind the mirror. I'll consider this side as a behind the mirror. There is no reference for that. Anybody? Why it is virtual? If virtual
So
is there,
because rays appears to meet, they're not actually meeting.
very good, excellent. Okay. So student, actual rays are going here. Actual rays are going here. They will never intersect. We have extended and they appear to meet. So what are these two rays? They are reflected rays. Reflected rays means what? Image characteristic they speak about. And we are also writing the image characteristics only. And they appear to meet means virtual. If the virtual word comes, erect word automatically comes. Okay. These are the four properties of the first case of the convex mirror. Okay, students. Four properties of case number 1. Okay. Okay. Case number 2 or the last case also you can say why. You keep object here, you keep object here, 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 here. Anywhere you keep object, I'll say it is case number 2 only. Why? The properties are same. Okay. So let us keep object at somewhere near center of curvature. Oh, it's somewhere over here. It is not at infinity. Infinity is finished. We finish this case. Now you keep object anywhere between infinity and pole, student. Infinity and pole. Okay. Obviously, now how should I start? Sir, you start with the parallel ray. You can take any ray again. Huh? I am just taking parallel ray. Okay, after hitting it, what will happen? A normal should be drawn. After that, what will happen? Reflected ray should go like this. But as it is a parallel ray, what should happen? It should definitely pass to the focus. It should definitely pass to the focus like this, student. Okay, like this. So it's an extended ray. Huh? It's an extended ray. So what should I do? I'll make this one with extended ray. Generally, we show by the dotted lines. Huh? Oh, extend. Okay, yes, Lavanika. Is it finished? Did we form the image, or should we take one other ray?
So we need another ray.
Which ray do you want to take?
I'm not sure about that.
So it is a ray number 1. Now you give me any idea that which ray do you want to take it. Anything you give it, student. Ray number 2, 3, 4, like that. Anything you shout out.
Mm, sir, I think, sir, can I animate it?
You want to animate it? Animate it.
It's just a guess, sir.
Okay.
How
Good.
about like this?
I'm not seeing your animation. Where are you? Achha, so you want to take ray number 4. You say me that I'll draw it. So you want to hit that particular instant at the pole? That is what you're saying?
Yes, sir.
Okay, you delete it, you remove it. I'll just
Yes. 1 minute.
undo it.
Yes.
Okay, so she want to take ray number 4. What is ray number 4? A light ray should come from the top of the object and should hit the pole. What will happen to the reflected ray? Reflected ray will maintain the similarity like this. Okay. Now one reflected ray is going here, another reflected ray is going here. Definitely they will not intersect. But what can I do? I can extend this reflected ray backside. Now, student, where is the intersection happening? Intersection is happening here. And where is the light ray coming from? Light ray is coming from the arrow. Let me draw the arrow, construct the other part. Okay. So now you can say where is the image formed? Between pole and focus. How is the image? It is diminished. How is the image? It is virtual and erect. Okay, virtual and erect. Yes, Rishit. She has taken ray number 4. So you try with ray number 3 beta. What is ray number 3, Rishit?
Like which is
Where should it pass through?
through focus, I guess.
No, that's ray number 2. That also you can take.
Oh.
No worries.
Sir, will it pass through C? Like center of curvature?
Exactly. Okay. So ray number 3. Let me take a ray that is passing through the center of curvature. But student, will the light go on the other side? It will not go. Then what should we do? We should assume that it is passing through the center. But what is the property of ray number 3? Whenever light ray is going to center of curvature, it will reflect back in the same direction like this. Now, where is the reflection happening? Here. Where is the image forming from? Here. So in this case also, you will get same thing, student. You will get same thing. That is how the property should be written. Case number 2. Okay. So from here, from infinity to pole, all comes under case number 2 only. And these are the properties. Diminished, erect, virtual, and image is formed between focus and you take any ray. Try to take the ray which you are comfortable in drawing. Okay, students, understood? Okay, yeah, this is what is given in your textbook. Okay, at infinity, position of the immediate focus, highly diminished or point size also you can write virtual and erect. From infinity to the mirror or the pole of the mirror, image will be between P and F, behind the mirror. Okay, you see, this is what she said, I guess. Behind the mirror is giving the word. Okay, which is what he is taking references. Always he is taking object as a reference. Okay, student, object is this side. So opposite side of the object will be behind. That's all. Okay, student, diminish virtual. Okay, if you have understood, try to give the answer. These 6 plus 2 cases are you need to remember in your sleep also, student. Very good, Rishit. Ritika, very good. Pranav, check yourself. Ridhima, right answer. Vishnu Maya, right answer. Lavanika, super. Yashasvi, awesome. Sai Chaitra, wonderful. Yes, Pranav, which mirror is he speaking about?
Concave mirror.
So, is it the case just we discussed or the last session?
Oh, the last session.
Yes, that is what the mistake is. Okay, it's a concave mirror. He's figured. So whenever student, now you see we have only finished the mirror. When I go to lens, again the more confusion. Why? There also concave mirror, convex lens, concave lens. So don't get confused. Look for the word very properly. First of all, mirror. Two options. Lens got deleted. Then concave. Then you should think about the 6 cases. So in the all the 6 cases, what we have? So we have that first 5 cases are first 4 cases are real and the last case is virtual. So we have both real and virtual. Okay, first 4 cases are all the images are real and the last case was virtual. So we have both real and virtual. Image formed by the convex mirror. Is anybody not giving the answer? Let me see. Vishnu Maya, image formed by convex mirror. So we have only 2 cases. Lavanika right, Vishmaya right, Ridhima right, Ritika right. 4 answers, 4 right answers. Pranav right, 5 answers. Come on, 4 more students are need to give it. Rishit, Yashasvi, Sai Chitra, Lavanika. Yashasvi right, 6 answers. Sai Chitra right, 7 answers. One more student, who is that?
Sir, I sent the answer and it's not like.
You gave the answer. You have not given. So which is the right answer, Rishit?
Sir, is it virtual image?
It is. Okay, it is virtual. Both the cases we are able to see that the image is erect only, beta. Erect means virtual. Okay. So student, what all we completed till now? Reflection of light completed. Plane mirror completed. Spherical mirrors terminology is completed. Sign convention completed. Okay, and important rays, 4 important rays also we have completed. Image formation by concave mirror completed, convex mirror completed. Okay, so now we are going to the numericals, but today we will not go, tomorrow we will go. But before that, there are some formulas in every numerical you need to use it. Okay, so the formulas are mirror formula and magnification formula. Mirror formula and magnification. Right? Okay, write the mirror formula, this one. I'll explain what is this. Mirror formula. Okay, students. Okay, so students, even though this formula is given in MCQs, we don't use this formula. We use much easier representation. Okay, so keep it same like that. I'll come to this formula. What is this? Let us understand that one formula I'm going to use. Let us understand the things in it. Okay, let us understand what all the things are in it. Okay, you see, I took some random case. I think this is a concave mirror. I took some case. So where will I keep the object? Here. Now, what is U? Object distance to the pole beta. This is known as U. Object distance is nothing but U. Now, what is U and object distance? Distance from pole to object. Distance from pole to object is U. Okay. Image distance. What is image distance? Where is the image? Here. From the pole. Okay. So that is represented by V. Your image distance is always represented by V. All our references are pole only. Okay. All our references are pole. Object distance Q, image distance V. Okay. And finally, the focal length, student. Focal length. Focal length. You see, distance between focus and pole. Focal length. Distance between focus and pole. Focal length. Sai Chetra, which type of mirror is this, beta? Sai Chetra, can you hear me? Which mirror? Concave. Now, can you say me, if at all in numericals, I want to take the focal length, focus point or focal length, will the point will be negative or positive? As per sign convention, you use the answer. You can see the concave mirror here and you can see focus here Now in the numericals, you should always go and write focal length value. So will that be in positive or negative? Others, give the answer in the chat box. As this is a concave mirror, in the numericals, we need to write what is the focus means plus 10 or minus 10. We should write like that with polarity. Now, according to the sign convention knowledge, whatever you have, will you give the focal distance or focal length of a concave mirror as negative or positive? Ritika, right answer. Vishnumaya, right answer. Rishit, right answer. Ridhima, right answer. Lavanika, right answer. Sai Chaitra, right answer. Very good. Yashashvi, right answer. Come on. Anybody who did not give? Pranav. You see, concave mirror, this is focus, student. This is different. Now, with the reference, is the focal point left or right? Pranav is not here.
Sir,
Ah.
left,
Yeah. So focal point is left to the origin or right to the origin?
left to the
Left
origin.
means negative or positive? From the origin left.
Negative.
That's all. So please write, student. Concave means always negative. Again, I'm not writing intentionally mirror here. Why? For length also it is negative. So please write concave focal length always negative. Concave focal length always negative. Don't write mirror. Don't write mirror. It is same for length also. There I'll explain again, but only write concave. Whenever you see the word concave, don't see whether it is mirror or lens. Just think, okay, it's का focal length negative रहेगा. Similarly, convex, this is a convex. When I complete the sphere, it is something like this, student. So obviously, its focal length will also be right side. Focal length of a convex is always positive, whether it may be mirror or lens. Focal length of a convex is always positive, whether it is mirror or lens. So whom should I ask today's notes? Let me see. Lavanika, Pranav, Ridhima, Rishit, Ritika. Yashashvi, send me your notes, student. Okay, whatever it is there, you don't make it very neat and clean. Whatever you are writing, you send me the photograph. Convex, focal length is positive. Okay, now let us see the formula, student. So, student, this is a formula which is given in your textbook, but I request you to write this formula. Write this formula. Yes, Lavanika. Is both the same? Are both the same? Check, look at mathematically and say, are both the formulas same? 1 by u plus 1 by v equal to 1 by f. 1 by v plus 1 by u equal to 1 by f. Mathematically, are they same or not?
So they are the same mathematically.
Yes, students, they are same. You can use any one of them. But I request you to remember this. Why? Because when I go to the lens now, only the middle sign will be changed. So it is easy to remember. If you remember here this way, when I go to the mirror, all the words will be confusing. So again, I'm requesting you, please remember this formula. 1 by v plus 1 by u equal to 1 by f. In your textbook, this is given. They both are mathematically same, students. That doesn't make any change. But remembering this makes it very easy when we go to lens. So here it is mirror formula. In the lens, it will be lens formula. Only the polarity will be changed.
So do we need to note the lens formula?
No, not now, not now. Tomorrow, day after tomorrow session. Okay, students. Yeah. So if we come to this point, you see this formula is same. This formula only. Why? D naught object distance u. Di image distance v. Focal length, focal length. So this formula both are same. It is little bit tough always. This thing you're not using in many of the books. This is what many of the books they are following. But some MCQs are there directly giving this. Even though the students know this formula, they are getting confused when they look like this. So that's the reason I frame this. 1 by d naught is object distance. D is O means object distance. Di is image distance. They both are same. Okay, students. Okay. Next is magnification formula. Please write, student. Magnification is a ratio of height of object to the height of, height of image to the height of object. So it is represented by m equal to hi by h naught beta. Either it is big H or small h also you can use it. Hi by h naught. Height of image by height of object. Riddhima, you can see two cases I took here. So now is this case image enlarged or diminished beta?
The image is enlarged,
Here image is enlarged or diminished?
diminished.
Diminished. If I say in which case it is magnified, which case has magnification factor or magnified?
The first case.
Oh. So student, even though we can use the word enlarged, diminished, but whenever he is speaking about the magnification factor, it is both the cases. Magnification factor, whenever he is using, he is asking to find the magnification, you should not say, sir, here there is no magnification. So we can't give the answer wrong. Both the cases, you need to use this magnification word. Enlarged, right? Diminished, right? But if I am saying the word magnification, it is both the cases. It is something like if my height is 6 feet, one student height may be 12 feet. It's not possible. I'm giving example. Okay, two times of it. One student may be half of my height. One student is two times of my height, and one student is half of my height. Both the cases in this chapter he will be taking as a magnification only. But one magnification will be more than one. Another magnification factor will be less than one. Okay, but in both the cases he will be using the magnification factor only. That's the reason whenever magnification comes, if he is asking in this case the magnification, you should not say there is magnification is not happening 0. No, you should give the answer something like half magnification, 1/4 magnification, less than 1. It is definitely less than 1. You should give these answers. So that's the reason whenever we are asking magnification, you should think that your magnification may be like this also, more than 1, like this also, less than 1. Understood, Sai Chaitra? Understood, beta?
Yes, sir.
Okay, so enlarge definitely only this case does not enlarge. Diminish only this case is not diminished. But magnification, both will be suitable for the magnification factor to be calculated. Okay, yeah, so please take another formula, very important formula. Now in tomorrow's numerical, you will be seeing which formula you need to use according to the given data. Magnification is hi by h naught equal to minus image distance to object distance. Hi by h naught equal to minus v by u, object distance to, image distance to object distance with a negative sign. This one not required, student. Not hi by h naught equal to minus v by u. Okay, if you have understood, let us do some questions. Focal length of a concave mirror is, just to think in the mind, concave mirror, how to draw. Sir, on the cave part, the light should come, the other side should be painted. So this is the principal axis. This is curvature, center of focus. Light comes and goes like this. Like that, you think and give the answer, student. If you are not remembering, if you are already remembering, then that's right. Lavanika, right answer. Sai Cheta, right answer. Ridhima, right answer. Vishnumaya, right answer. Pranav, right answer. Shishishvi, right answer. Nishit, right answer. Come on, Ritika. Ritika, right answer. Negative. Concave means don't look at the second word at all. Right? Negative, that's all. Focal length of a convex mirror is, obviously this is just opposite, right? Yes, student. Okay, so convex is something like this. Inside it is painted, but when you draw the sphere, it is something like this. So focus will be right side, center will be right side, focus will be right side. So it is right side positive. This way you need to, if you remember this logic, then you will not forget things. Okay, Ridhima, Sai, Chitra, 11. Right after. So one more formula I need to give straight. Focal length of a spherical mirror. You see, this is a concave mirror. If I want to complete this, let me complete with this spherical mirror. Okay. Now, yes, Vishnu Maya, from center of curvature to pole, what is this distance known as? From center of curvature to pole. Yes, beta. Radius of curvature, right answer. Yes, Ritika, Pranav, right? Radius of curvature R. Okay. Now, what is focal length? Focal length is nothing but distance between, I'll use the black color, distance between focus and pole. Okay. So this student, this will be exactly half R by 2. Or else you can say, sir, center of curvature to here, if it is 10 centimeters, this will be 5 centimeters. Your focal will be exactly half of the half of the radius, student. That is what I want to say. Your focus will be exactly half of the distance between center of curvature and pole, or you can say half of the radius of curvature also. So your answer should be C, R by 2. Yes, no, Ridhima. Okay, right answer. Okay, half of the radius of curvature is nothing but focus, beta. Focal length we need to say. Focal length. Focal length is nothing but half of the radius of curvature. Right answer, Ridhima, Lavanika, Ritika, Pranav, Rishish, Yashashvi. Come on, who else? Vishnu Maya. All of you? Okay, obviously it is. Okay, yeah. So from tomorrow we'll be doing small numericals followed by big numericals. Tomorrow we'll complete the mirrors. Okay. Day after tomorrow, lens is very easy. I think we can complete in one session also. I'll try to close by this weekend. Okay. If not, next Monday I'll close this chapter and we'll move to biology first chapter. Okay. That is also very big chapter. I don't know how many days. This physics and biology first chapters are very big. Chemistry is somewhat okay. Chemistry third chapter is very big. Metals and non-metals. Okay, students, that's all from my side. Any doubts you can ask me. Or else thank you for joining.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Thank you.